everybody, I hope you guys are having a good day today. So in this video, we're going to talk about exponents and the order of operations. So let's start off with exponents. So if a and m are two whole numbers where m is not equal to 0, then we define exponents so that a to a power of m, where m is the exponent, equals the result of multiplying a by itself m number of times. So for example, if a was the number 2 and m was the number 3, 2 to the third power would equal 2 times 2 times 2, which would equal the number 8. And so this is the way that we define whole number exponents. And notice that in this definition, the exponent m was not allowed to be 0. But we do define a 0 exponent based on the pattern of how the other exponents work. So for example, if we have 5 to the third power, that's 5 times itself 3 times, which equals 125. 5 squared is 5 times 5, which is 25, and 5 to the first is just 5, which equals 5. And if we look at the pattern here, we notice that to get from 125 to 25 and to get from 25 to 5, the pattern is that we're consistently dividing by 5. Because 125 divided by 5 equals 25, 25 divided by 5 equals 5. And so if we continue this pattern and we divide by 5 one more time, well, 5 divided by 5 equals the number 1. And so this is the reason why 5 to the 0 power equals 1. And this will be true even if you have another number. Because if you had 2 to the third and 2 squared and 2 to the first, and you were trying to find 2 to the 0, well, 2 to the third is 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. 2 to the first is 2. And you'll notice that there's a similar pattern where we're consistently dividing by 2. And so regardless of what the number is, if you do any number to the 0 power, you get the number 1. And that's the way that a 0 exponent is defined. And incidentally, this is also how negative exponents are defined, because if you do 1 and you divide by 5, that gives you 1/5. And if you do 1/5 divided by 5, you get 1/25. And this is equal to 5 to the negative 1 and 5 to the negative 2, because negative exponents create reciprocals. So like 5 to the negative 2 is the same thing as the reciprocal of 5 squared. So you won't see any negative exponents in your homework, but just as kind of like a heads up, that's why negative exponents create reciprocals, because it's basically continuing this pattern of consistently dividing by 5 or whatever the base of your exponent is. So when we're working with exponents, we have 4 different exponent theorems that we're going to be looking at. And I want to go through and show you why these exponent theorems actually work. So the first exponent theorem says that if you have any number raised to 2 different exponents and you multiply those powers together, that the result is going to be that base number raised to an exponent of the 2 different exponents added together. So to see why this works, let's plug in some different numbers and look at this. So let's say that a is the number 2 and m is the number 3 and n is the number 5. Well, if I have 2 to the third power times 2 to the fifth power, I'm going to have 2 times 2 times 2, and that is going to be multiplied by 2 times 2 times 2 times 2 times 2, 5 times. And if you look at that, well, it's all multiplied, and the associative property of multiplication says it doesn't matter which ones you multiply together first. And so basically, I'll have 8 2's all multiplied together. And so this is the reason why this equals 2 to the 8th. And if we look at the pattern in the numbers, you can see that the exponents were basically added together. And this is the reason that if you multiply 2 powers with the same base together, you can add their exponents to simplify them. So what happens if you multiply together 2 numbers with different bases but the same exponent? Well, if we look at an example of this, let's say we have 2 to the, fourth power times 3 to the fourth power. This problem is saying that this is equal to 2 times 3 to the fourth power. And if we expand this out, we can see why this is true, because 2 to the fourth power is going to be 2 times 2 times 2, 4 times, and then 3 times itself 4 times as well. And this makes sense that this would equal 2 times 3 times itself 4 times, because that's basically just rearranging the multiplication. And it's just saying that I'm going to rearrange the multiplication so that this 2 and 3 are multiplied together first, and this 2 and 3, and this 2 and 3, and this 2 and 3, and then those will all be multiplied together. And so this theorem is due to the commutative property, which says that you can switch the order of multiplication and still get the same results. And then we have the theorem that says that if you raise a power to a power, that you can multiply these two exponents together. So let's say, for example, we had 2 to the third power, and this was raised to the fourth power. Well, 2 to the third to the fourth power means that I'm going to have 2 times 2 times 2, and that is going to be multiplied by itself 4 times. So that looks like this. And notice that the number of 2's that are all multiplied together is 12, and so this equals 2 to the 12th power. And this is the reason that you can multiply the exponents together when you have a power raised to another power. And then our last exponent theorem says that if you divide two powers with the same exponents, that you can subtract those exponents. So let's say, for example, I had 3 to the 7th divided by 3 to, let's say the 5th or something. So if I were to write this out, I would have 3 times 3 times 3 times 3 times 3 times 3 times 3, 7 times. And I'm going to divide this by 3 times 3 times 3 times 3 times 3. And if you divide 3 by itself, it cancels out to 1. So 3 divided by 3 cancels out to 1. 3 divided by 3 cancels out to 1, cancels out to 1, cancels out to 1, and so forth. And so my result is going to be 3 squared because I have 2 3's multiplied together. And you can see if we look at this pattern up here, 7 minus 5 equals the number 2. And so that's where that last theorem comes from. And when you're teaching this to your students, I would recommend explaining it in a way where they can really understand where the theorems come from. Because again, it's much easier to remember these if you know where they come from versus if you're just memorizing a rule. So going through some examples like this with your students can help them identify those patterns for themselves. And when you introduce exponents to your students, you'll also introduce the order of operations pretty soon afterwards, because the order of operations tells us what order we need to do operations in if you have multiple things in the same problem. So like if you have exponents and subtraction and division, how to determine which ones you do first. Because the order that you do them in matters, and it makes a difference in regards to your final outcome. So one of the most common ways that you've probably heard of before to remember order of operations is PEMDAS, which you can also use the mnemonic, please excuse my dear Aunt Sally, to remember. And basically what PEMDAS says is you need to do parentheses first, and then exponents, and then you do multiplication and division from left to right, whichever one comes first. And then you do addition and subtraction from left to right, whichever one comes first. And there's also other mnemonics that you can use as well, like GEMS. So GEMS stands for groupings, exponents, multiply, and subtract. And like this kind of shows that multiply and division are like lumped together. And addition and subtraction are also lumped together, and you need to work from left to right. So you can use either one of these mnemonics, but I want to point out some problems that often come up when students learn the order of operations using PEMDAS. So when you're solving a order of operation problem, you do parentheses, then exponents, then multiplication and division from left to right, and addition and subtraction from left to right. And so if you were to solve this problem, you would look at it and you'd say, well, I don't have any parentheses, I don't have any exponents, but I do have some multiplication and division, so I need to do it from left to right. So I would say, okay, well, 64 divided by 8, that's going to give me the number 8. So I would have 100 minus 8 times 4 plus 6. Then I can do my multiplication, and 8 times 4 is 32. So I'd have 100 minus 32 plus 6. And then I would do addition and subtraction from left to right. So 100 minus 32 is 68 plus 6. And then if I do my addition, that's going to give me the number 74. And this is the correct way to use the order of operations. However, there's a very common mistake where the students will forget that multiplication and division are supposed to be lumped together, and addition and subtraction are supposed to be lumped together and done from left to right. And so the way that I've seen a lot of students solve a problem like this is they'll say, okay, I have no parentheses, I have no exponents, I do have some multiplication, so I'll simplify that, and I'll get 100 minus 64 divided by 32 plus 6, because 8 times 4 is 32. And then they'll say, okay, now I don't have any multiplication, but I do have division. So 64 divided by 32 is 2. So I have 100 minus 2 plus 6. And then they'll say, I do have addition. So I'll do 2 plus 6 is 8. That gives me 100 minus 8. And 100 minus 8 is 92. And they'll say that this is the answer. But you can see this is a very different result than the correct answer, which should be 74. And the reason they got a different result was because they didn't do multiplication and division or addition and subtraction from left to right. So when I'm teaching my students the order of operations, I actually prefer not to use PEMDAS or any mnemonic for it. And instead, I talk about how the order of operations is based on the way that math is built. So if you think about when you first start learning math, the first thing you learn is addition. And then you learn that addition can be undone with subtraction, because subtraction is the inverse operation for addition. And then you learn that repeated addition is multiplication. Then you learn that the opposite or inverse of multiplication is division. And then you learn that repeated multiplication makes exponents. And later, in like 8th grade, I think it is, you learn that roots undo exponents. And so math is kind of built on these layers where repeated addition becomes multiplication and repeated multiplication becomes exponents. And so I like to teach my students that order of operations basically says that you work from the hardest level down. And if they want you to work in an order that's different than that, then they'll put parentheses around it. And so the way that I explain it is that it's kind of like a pyramid, and you always do parentheses first, and then after you do parentheses, you just work your way down the pyramid, working from left to right. And so you do exponents if you have any exponents, as well as any roots. If you have any multiplication or division, you do those ones from left to right. And if you have any addition and subtraction, you do those from left to right. And I found that teaching order of operations in this way actually works a lot better, and it usually is easier to remember. So to practice using order of operations, I want you guys to pause this video and go through and solve each one of these 4 problems by working your way down the pyramid. So remember, you start with parentheses, and then you do exponents and roots, then multiply and divide, and then add and subtract. So pause this video and then restart it to see how I would solve it. Okay, so on this first one, I first want to simplify my parentheses. However, inside of my parentheses, I have multiple operations. So I need to use the order of operations inside of my parentheses to simplify them. So in my first set of parentheses, I have both multiplication and division. So I'm going to work from left to right to simplify that multiplication and division. So 1 times 4 is 4. 2 divided by 2 is 1, and so I'm going to have 4 minus 1 in that parenthesis. Then in my second parenthesis, I don't have any multiplication or division, and so the operation I'm going to work on in this parenthesis is 6 plus 2, which is 8, minus 3, which is 5, because addition and subtraction are on the same level of the pyramid, and so I can do those from left to right. So this parenthesis right here, I don't really need anymore because I just have a single number in it. But I do still need these parentheses because I haven't figured out what that parenthesis simplifies to. So 4 minus 1 is 3, and I have 2 times 3 plus the number 5. And now that the inside of my parentheses are simplified, now I can do order of operations on the expression as a whole. So I say, okay, I have multiplication and addition, but multiplication is farther up the pyramid and it's a more complicated operation, so I need to do that first. So 2 times 3 is 6, then plus 5, and when I do 6 plus 5, that equals the number 11. And so the answer to this first one would be 11. On the second problem, I'm again going to simplify my parentheses first, but inside of my parentheses, I have multiplication and exponents and division. So I'm going to start at the exponent level of the pyramid and simplify that. So that gives me 3 times 25 divided by 15. And then in my second set of parentheses, I also have exponents, so I'm going to simplify that, and I get 5 minus 4. Now I still need to simplify my parentheses, and in my first set of parentheses, I have multiplication and division, which are on the same level of the pyramid, so I'm just going to go from left to right. And 3 times 25 is 75, and 75 divided by 15 is 5, I think. Yeah. And then 5 minus 4 in my second set of parentheses is 1, so I'm going to get 5 minus 1. And 5 minus 1 equals the number 4. So that would be the correct answer for that one. On this third one, I'm going to simplify my parentheses, and I actually have 2 sets of parentheses. So I need to simplify my innermost set first. So in my innermost set, I have subtraction and multiplication. And so I need to simplify my most difficult operation first, which is multiplication. So I'm going to have my brackets and 3 minus 28 divided by 5 minus 2 times 24 divided by 6. So now I'll keep simplifying my parentheses, and 3 minus 28 is negative 25. So I get negative 25 divided by 5 minus 2 times 24 divided by 6. And negative 25 divided by 5 is negative 5. And in later lessons, we'll talk about why a negative divided by a positive is a negative. But hopefully you should still know that rule just from previous math classes. And so I have negative 5 minus 2 times 24 divided by 6. And so now that my parentheses are taken care of, now I'm going to look for any exponents, but I don't have any exponents. So then my next step would be to do multiplication and division from left to right. So 2 times 24 is going to be 48. 48 divided by 6 is 8. So I get negative 5 minus 8, which equals negative 13. And that would be my answer for that one. And then for this last problem, I'm going to start off by simplifying the stuff in the parentheses. So 1 to the 4th equals 1, because if you do 1 times 1 times 1 times 1, that's going to equal 1. Then we multiply this by 2 squared, which is 4, because 2 times 2 is 4, plus 27, because 3 times 3 is 9, times 3 again will give you 27. And all of this is still in parentheses, minus 2 to the 5th divided by 4. Then I need to continue simplifying inside the parentheses. So inside the parentheses, I have multiplication and addition, and multiplication is a higher level of the pyramid, so I'm going to do that one first. So 1 times 4 is 4, plus 27 is inside of the parentheses, minus 2 to the 5th divided by 4. 4 plus 27 is 31, and I have 31 minus 2 to the 5th divided by 4. So now that my parentheses are taken care of, now I need to do the order of operations on the entire expression. So I have exponents, so I'll do 2 to the 5th, which is 2 times 2 is 4, times 2 the third time is 8, times 2 the fourth time is 16, and times 2 the fifth time would be 32. So I end up with 31 minus 32 divided by 4. Then I need to do division because that's the next most difficult operation. So 32 divided by 4 is 8, and I end up with 31 minus 8. And 31 minus 8 is going to equal 23. And so 23 is the correct answer on that one. So that's how you do order of operations. If you guys have any questions, let me know. And I hope you guys have a great day.